Imagine the void of space, a silent canvas where ancient rocks drift like forgotten whispers from the dawn of our solar system. These celestial wanderers, asteroids, carry within them metals forged in the hearts of exploded stars, elements that could rewrite the fate of humanity. Picture a single asteroid, Psyche, a metallic behemoth hurtling through the darkness, its core estimated to hold iron, nickel, and precious metals worth $10 quintillion, a sum so vast it dwarfs the global economy, promising riches beyond earthly dreams. Yet in this promise lies a paradox. What if unlocking these treasures unleashes forces that could unravel the very fabric of our world? We gaze at the night sky, seeing pinpricks of light, but beneath that veil, these stony sentinels hold secrets of creation and destruction, their surfaces scarred by eons of cosmic violence. They are remnants of failed planets, born from the same nebula that birthed our Earth, yet they roam free, untethered, carrying the building blocks of life and industry. How strange that something so distant, so inert, could hold the power to elevate civilizations or plunge them into chaos. We stand on the precipice, peering into this enigma, where the allure of infinite wealth dances with the shadow of unforeseen peril. In the quiet expanse, these asteroids pulse with hidden potential, like buried hearts beating in the cold. What stories do they tell of our origins, and what warnings do they whisper about our future? Venturing deeper into this cosmic theater, we find ourselves amid the asteroid belt, a vast ring of debris stretching between Mars and Jupiter, a graveyard of planetary aspirations. Here, billions of fragments orbit the sun, remnants from the solar system's turbulent infancy 4.5 billion years ago, when gravity's dance failed to coalesce them into a full world. Some are mere pebbles, others colossal worlds unto themselves, like Ceres, the dwarf planet that reigns as the belt's queen, its icy surface hiding subsurface oceans that might cradle microbial life. But it is the metallic asteroids, the M-types like Psyche, that captivate our imagination most profoundly. Psyche, discovered in 1852 by Italian astronomer Annibale de Gaspari, measures about 140 miles across, a potato-shaped enigma composed almost entirely of iron and nickel, the exposed core of a protoplanet stripped bare by ancient collisions. Its value, calculated by astronomers at NASA's Jet Propulsion Laboratory, stems from these metals, enough iron to supply humanity's needs for millions of years, platinum and gold in quantities that could crash markets or fuel technological revolutions. We contrast this with Earth's own resources, finite and depleting. Our planet's crust yields metals through arduous mining, scarring landscapes and poisoning waters, while asteroids offer a pristine harvest, untouched by biology or weather. Yet, the scale overwhelms. The belt contains perhaps 1 million asteroids larger than a kilometer, each a potential vault of elements like rhodium, used in catalytic converters, or palladium, essential for electronics. Emotionally, this expanse evokes reverence, a sense of standing before nature's grand vault, where the sun's distant light glints off jagged surfaces, casting long shadows that mimic earthly canyons. We feel the pull of exploration, the same that drove sailors across oceans, now extended to the stars. Philosophically, these rocks challenge our notions of ownership. Who claims the heavens? In their silent drift, they remind us of our smallness, yet ignite a fire of possibility where harvesting their bounty could end scarcity, powering fusion reactors with helium-3 from lunar-like regolith or building space habitats with infinite steel. But woven into this tapestry is the peril. What if this rush mirrors the gold fevers of old breeding conflict in the vacuum? The narrative unfolds like a slow orbit, drawing us into the heart of these wandering worlds where science and dreams collide in the endless night. Delving into the hidden signals that betray these asteroid treasures requires tools beyond our naked eyes, instruments that pierce the veil of distance and decode the language of light. Astronomers rely on spectroscopy, capturing the unique fingerprints of elements as starlight reflects off asteroid surfaces, revealing compositions through absorbed wavelengths. Iron shows its mark at 430 nanometers, a subtle dip in the spectrum that whispers of metallic cores. For Psyche, data from ground-based telescopes like the Very Large Telescope in Chile first hinted at its anomaly, with infrared observations showing a lack of silicates, suggesting a pure metal body. an oddity among rocky brethren. Radio waves, too, play their part. Radar echoes from facilities like Arecibo, before its collapse, bounced signals off asteroids, mapping their shapes and densities, confirming Psyche's hefty mass, far denser than stone, pointing to a nickel-iron heart. These detections build intrigue, like intercepting coded messages from a distant ally, where anomalies in orbital perturbations, slight wobbles caused by gravitational tugs, reveal hidden companions or internal structures. Consider the light curves, graphs of brightness variations as asteroids tumble, exposing facets that reflect sunlight unevenly. For resource-rich bodies like Bennu, sampled by NASA's OSIRIS-REx mission, these curves unveiled carbon-rich surfaces laden with organics, precursors to life. The tension mounts as we realize these signals are not mere data points but echoes of cosmic history. Gamma rays from radioactive decay hinting at volatile ices beneath, or thermal emissions captured by infrared satellites like NEOWISE, classifying asteroids as potential threats or treasures. Scientifically poetic, this process evokes wonder, transforming cold vacuum into a symphony of information, where each wavelength carries a story of formation and survival. We sense the growing pull, the intellectual hunger to unravel what instruments alone can see, bridging the gap between human curiosity and the universe's guarded secrets. In this shared journey through the stars, we pause to feel the warmth of connection, as if the asteroids themselves invite us to reflect on our place in the cosmos. Their ancient metals, forged in stellar furnaces, mirror the resilience within us, reminding that we, too, are stardust seeking meaning in the vastness. Tracing back to the beginning, we reconstruct the primordial chaos from which asteroids emerged, a tale etched in fire and dust across billions of years. In the solar system's nascent nebula, a swirling disk of gas and particles collapsed under gravity's inexorable pull, birthing the sun at its center, while remnants clumped into planetesimals, embryonic worlds that collided and merged. But in the volatile zone between Mars and Jupiter, Jupiter's massive gravity disrupted this harmony, preventing a planet's formation and scattering debris into the asteroid belt we know today. These fragments, frozen in time, preserve the elemental purity of that era. Carbonaceous asteroids like Ryugu, visited by Japan's Hayabusa 2, hold water ice and amino acids, the very building blocks that may have seeded Earth's oceans and sparked life. Metallic ones, like Psyche, likely originated as the molten cores of larger bodies stripped by cataclysmic impacts that vaporized outer layers, leaving naked iron hearts to cool in the void. Philosophically, this evokes a nostalgic reverence, as if we're witnessing the universe's mythic birth pangs, where elements heavier than helium, forged in supernovae eons before, rained into the nebula, enriching it with gold, platinum, and rare earths now locked in these rocks. Time stretches here like an ancient river, carving paths through cosmic dust. Consider how isotopic dating, analyzing uranium-lead ratios in meteorite samples from asteroids, pins their age to 4.6 billion years, aligning with Earth's own genesis. We delve into sub-narratives, like the case of Vesta, a differentiated asteroid with a crust, mantle, and core, its basaltic surface scarred by a massive crater that exposed deeper layers, offering a window into planetary evolution halted midway. Emotionally, this reconstruction stirs a sense of elemental kinship, as if these asteroids are our cosmic siblings, born from the same cradle yet destined for eternal wanderlust. Their slow formation, particle by particle, mirrors the patient assembly of human knowledge, layer upon layer, revealing order from disorder. In deeper reflection, we ponder the fragility of such births. Had Jupiter formed differently, a fifth planet might orbit there, altering life's trajectory on Earth. Instead, these relics endure, guardians of secrets, their metallic veins pulsing with the potential to fuel humanity's next epic, or perhaps echo warnings of gravitational disruptions that could one day hurl them toward us. Framing science as a custodian of memory, we explore how asteroid discoveries unfold by sifting through ancient light and captured particles, reading the universe's archived tales. Meteorites, fallen fragments of asteroids, serve as time capsules. The Allende meteorite, which crashed in Mexico in 1969, contains calcium-aluminum inclusions dated to the solar system's earliest solids, their chemistry revealing temperatures and pressures of the primordial disk. Telescopes like Hubble capture light from asteroids that left their surfaces millions of years ago, allowing us to peer into the past, while sample return missions bring physical relics to labs, where mass spectrometers decode isotopic signatures, tracing origins to specific belt regions. This methodical curiosity uncovers how volatiles in asteroids like those in the Hilda group preserve water from the outer solar system, potentially explaining Earth's oceans. Lyrically, it's like unearthing a library of stardust, each grain a verse in the cosmos' epic. The voices of evidence resonate through the scientific community, where missions like NASA's Psyche spacecraft, launched in 2023 toward its namesake asteroid, embody human ingenuity. Led by principal investigator Linda Elkins-Tanton, the mission employs gamma-ray spectrometers and magnetometers to map Psyche's composition, building on discoveries from the Dawn mission, which orbited Vesta and Ceres from 2011 to 2018, revealing hydrated minerals and cryovolcanoes. Groundbreaking studies, such as those published in Nature Astronomy in 2020, estimate Psyche's metal content could indeed reach that staggering $10 quintillion, while the European Space Agency's Hera mission, set for 2024, will study the aftermath of NASA's DART impact on Dimorphos, advancing planetary defense. These efforts, involving astronomers like Vishnu Reddy, highlight timelines of progress, from early radar mappings in the 1970s to today's AI-driven data analysis, all grounded in peer-reviewed precision, yet laced with the poetry of discovery. Beneath the visible surfaces lie invisible landscapes, subsurfaces teeming with hidden structures that shape asteroid realities. Probing with seismic waves simulated in models or radar penetration, we uncover porous interiors like Bennu's rubble pile nature, a loose aggregate held by weak gravity, defying expectations of solidity. Dark matter's subtle influence might perturb orbits over eons, while quantum effects in metallic lattices could enable novel material properties, evoking awe for these unseen depths. Comparisons fluidly arise. Just as Earth's mantle hides convective currents driving tectonics, asteroids conceal fractured zones from impacts, potential reservoirs of ices or organics. The suspense builds in contemplating density gradients, where Psyche's core might harbor remnants of magnetic fields, fossils of ancient dynamos, contrasting with the vacuum's stark emptiness. Life against all odds manifests in the resilience of extremophiles, mirroring potential asteroid habitats. On Earth, microbes in Antarctic dry valleys or deep-sea vents endure radiation and vacuum-like conditions, much like hypothetical life in Europa's subsurface ocean. But asteroids push this further. Bennu's samples revealed glycine, an amino acid suggesting organic persistence in space's hostility. We compare this to human endurance, survivors of disasters drawing strength from inner reserves, a wondrous parallel where biology defies entropy, fostering hope that life clings even in the void. Expanding to refuge worlds, we envision moons like Europa, with its cracked ice shell hiding a global ocean warmed by tidal forces, potentially harboring chemosynthetic life akin to Earth's black smokers. Titan's methane lakes and thick atmosphere offer organic chemistry labs, while Enceladus spews water plumes rich in salts and organics. Shocking facts like Cassini's detection of hydrogen gas pointing to hydrothermal vents. These environments, compared to asteroids, broaden our hopeful gaze, imagining microbial oases enduring cosmic isolation. This awareness sharpens through tension, urging us to confront the urgency of our choices amid these celestial possibilities, linking personal reflection to the vast cosmic dance. Human scars parallel these cosmic themes as our earthly mining ravages ecosystems. Think the Amazon's deforestation for gold, mirroring asteroid exploitation that could spark space conflicts or economic collapses, breeding inequality where corporations claim heavenly resources, leaving societies in ruin. The collapse in motion unfolds viscerally. Envision unregulated asteroid mining fleets stripping Psyche, debris clouds triggering Kessler syndrome, satellites crumbling in chain reactions, isolating Earth in darkness. Economically, flooding markets with metals crashes values, dooming industries. Environmentally, failed retrievals hurl toxic fragments planetward, accelerating climate chaos in a poetic realism of unraveling systems. Hidden stakes reveal invisible forces. Political rivalries like US-China space races drive mining agendas, with the Outer Space Treaty of 1967 ambiguously allowing resource use. Yet economic motives from companies like Planetary Resources fuel conflicts, analogous to historical colonial grabs. Moral dilemmas emerge. Should profits fund sustainability or exacerbate divides? Global patterns echo oil wars, weaving contemplative intensity. Future on the Balance presents a fork. One path, dystopian, sees corporate greed ignite interstellar wars, resource depletion mirroring Earth's, humanity fractured in scarcity. The other, hopeful, harness personal responsibility for collaborative mining, channeling wealth to renewable tech, fostering unity. Reflections weave in, conditional visions lifting emotions toward climax. In reflective closure, we tie this narrative's threads, stirring introspection on our cosmic legacy, a quiet resonance echoing through the stars. What echoes from the opening mystery now reframes. If asteroids hold treasures to save or doom us, how will we choose to unlock them? In wisdom or folly? Legacy in Light connects to humanity's journey, where asteroid mining could etch our survival in the stars, ethically balancing progress with preservation. Lessons from past empires guiding species-level ethics across generations.